So finally, we've reached our main event. We are finally talking about normal distributions. And we're going to begin by talking about the standard normal distribution. When we're working with probability, it's important to keep in mind that we're actually talking about theoretical distributions. So these are models. They are an ideal that in practice can never really be attained. So if we're talking about it in terms of a frequentist approach, we may have a random sampling process where we're obtaining values for a sample, and we obtain as many as we want, maybe 100, maybe more, and they all take on different values in the support of this random variable that we're going to call z. So each one of these, right, has a certain value, and when we take them and turn them into a histogram, we'll get something that approximately looks like we have a bell curve. So we've talked about what this bell curve shape looks like before, but now we're actually going to talk about what the ideal distribution looks like. So we say z has the standard normal distribution when it has a few key characteristics. So first, its mean is 0. Its standard deviation is 1. So remember, we're talking actually about expected value. And the standard deviation that comes from expected value. This is the probabilistic interpretation of mean and standard deviation, but we'll use those words interchangeably from now on. And 3 has a bell-shaped symmetric density curve whose and we call that PDF. The PDF is written phi of x. And warning, incoming math, the specific PDF for any value in the support, so any real number, it's going to be 1 over the square root of 2 pi times e to the negative x squared over 2. Now, we're not actually going to deal with this PDF. We're also not going to deal with its CDF directly. Its CDF is denoted using a capital pi, a capital phi, and that's the probability that z takes on a value less than or equal to this x that we talked about. So remember, what we're actually looking at is now we're talking about a density curve that looks like this. It takes on values between negative infinity and infinity, but it has its peak at 0. It's perfectly symmetric. So the tail regions are of the same size either way you're looking at it. Okay, now I guess I gotta shift the 0. Okay, and you go 1 to the left, 1 to the right, and you have your first range of standard deviations. 2 standard deviations out is negative 2 and 2. Then 3 standard deviations out is 3 and negative 3. And our typical range of values lie between negative 3 and 3. So this would be the PDF. So this is the density curve. And the area underneath the density curve, say if we're looking at this area, means that we're looking at phi of -1, which is the probability that a random value distributed according to the standard normal distribution is going to be less than or equal to -1. Sorry. Now, how do we actually find these probabilities? How do we find percentiles for the standard normal distribution? We're not going to be using the actual PDF and CDF functions. What we're going to be using is technology. So to actually find these values, we have a couple of different tools in our arsenal. So the first, which is the more traditional method, is to use a cumulative area table So in another video, we're going to talk about how to actually use a cumulative area table. And there's one in the appendix for this book. But what it will do is we're going to use this table that has a whole assortment of different values, and that'll help us find both probabilities and percentiles. You can also find one online. It's pretty easy to find as long as you search cumulative area table and then specify that we're looking for one for the standard normal distribution. You can even avoid writing down all these words by just writing Z table. So colloquially, you could call it a Z table. Secondly, and this is why having a TI-84 is so important, or if you have an 83, that'll work too. The TI-84 has a function called normal CDF. So this function is under the distribution menu. We'll never use normal PDF, so just wipe that from your mind. Don't even think about it. That doesn't mean anything to us. But the normal CDF is what we'll use to find areas / probabilities. And if you use inv norm, your calculator may or may not have this depending on which model you have. Inv norm will give you percentiles. And we'll talk about that briefly later. So we will be using the standard normal distribution for a whole host of different applications. And in a future video, we're going to be talking about those applications and how to actually work with these things.